Welcome to another episode of All the Ideas by the Mad Fellows. I am Dan Servo, and this is Doug Bebb.
So, I was wanting to get your opinion on this one. Different ways of checking your inputs. Do you prefer to poll and interrupt?
So polling versus interrupt.
Yeah.
This was the question that was proposed to us at that one group, right?
Yeah.
Yeah. No, that's very interesting in a general sense, because what do you do when you need to get data from an actual physical or a timed situation?
Yeah, well, I think first thing that comes to mind is like if you're doing some kind of a controller.
Okay, like a game controller, right?
Yeah. What would be the better way to do it? Sit there listening, waiting for somebody to push a button, because you don't want to miss it, right?
Yeah.
But or do you just rely on an interrupt?
Well, I mean, it really does depend. I mean, there's, on the game controller system, right? You don't want to miss the button press, but you also don't want to be constantly sending data to another, to your other system. So like say on an NES, where you have a game controller that has the actual microcontroller in the controller itself, and then you have the microcontroller of the game console, and there's a communications between the two. You want to collect a whole packet of data to send to the NES, but you don't want to miss any of the button presses. So you're probably going to want to interrupt on the controller, but then pull the data, or push the data even to the NES.
Okay, so in that situation you do that, but what about, like if you're going to time something like velocity of a rocket?
Okay.
That came up one time.
Yeah, that was down Heatsink, wasn't it?
Yeah, it was.
Well, yeah, that would be a situation where you want to start it with an interrupt and end it with an interrupt, because it is critical that you know point A, point B. When you're doing things that are not as critical of timing, where you're not measuring a velocity or something like that, you can kind of pull. But you'd still always run into the risk of missing an input.
So the longer your code gets, the better, worse your chances of actually catching something that you need to.
Yeah. If it's absolutely critical that you need it, interrupt. I mean, this is going to be a similar situation to you and Saab.
Yeah.
Saab never always interrupted when it wanted communication.
Mm-hmm.
So, I mean, that's...
Yeah, and otherwise it just stays idle. It doesn't take up a lot of processor time. You can keep on doing something else not related to that. And then when it needs to kick in, then the interrupts will get it to do it.
Yeah, I mean, it really is, mission critical. What is my, me receiving this going to change it, so bad that it's not going to make a difference? I know, like, Stack It in the Pro Arduino book needed to be interrupted, so it always caught the input of the player.
Mm-hmm.
But there's plenty of times where I've just pulled the information. Just sat there and checked, okay, it's not pressed, I don't do this. But I mean, you're running at least some decent speeds. You're not gonna, if you're not doing a lot of delays, you have less chance of missing things. I mean, this all comes down to, microcontroller development, not, computer programming.
Okay, so we've got a couple of different options here. The kind of, compare and contrast against each other. You've got polling. I think one advantage on the Arduino of polling your pins is that you could be looking at a particular pin all the time. If you're going to use an interrupt vector, you do have the problem of during critical pieces of code, you might have the interrupts turned off.
Yeah, you might have to turn an interrupt off to run your critical crunch.
Yeah,
you don't want it interrupting at this point.
So you still might miss something even if you're going to use an interrupt. And so even though polling is very resource intensive, you're going to have a very likelihood if you're just looking at, say, this pin.
Yeah.
One pin that you're going to catch it.
Yeah.
And you're going to catch it right away. Whereas an interrupt, then you have to jump into it. It has to, put everything back to an idle to then look at this task.
Yeah, it has to jump. In computer programming, this is usually, on a bigger, PC, a microprocessor, not a microcontroller. you have the ability to do a lot more with threading and listeners and stuff like that than you would with, say, a simple AVR chip or a PIC chip.
Yeah. And yet I think for most input devices, people are going to combine the real world to a microcontroller, at least before they then get to a microprocessor. So even if they take it, to some of the higher levels of processing ability, they're still going to be capturing it with the microcontroller.
Yeah. I mean, it is good news that, with human speeds, any kind of real human input, you're very hard pressed to get a lot of stuff where you're going to miss a human input.
Well, yeah, I suppose if you had long loops or anything like you're transferring a large data file, from an SD card or something, you might end up having a code delay for so long you're not going to notice something. That actually reminds me of one thing that we had mentioned when we were talking about this before, was to create a latch.
Yeah. That was, the other thing is, what other unique solutions can you get into? If it's going to be intermittent, but you need to catch it when it, happens. Say, you have a, Zener, a Schmidt trigger, trying to wait for an analog input to reach a certain point, and that, based on, say, like chlorine concentrations in the water, and you're building a PID controller at a chlorine plant. And when that, concentration reaches a certain point and triggers the, Schmidt, you might not catch it right away. So you'd want to like run it through a latch, and then the program could then come through and go, oh, it's triggered since the last time I, checked it.
I mean, so that's really if you're going to bring it outside of the microcontroller itself. So if you're just using an Arduino board, you're going to need a little bit of extra hardware.
Yeah.
But, then you have the ability, you're not going to miss anything.
Yeah.
Maybe you don't need it critically. I don't need to know it this instant what happened, but when I get to it, I want to know if it was pushed.
Like, yeah, I'm not timing something. If I'm timing something, I'm going to want to, definitely interrupt.
Yeah, I think this would be actually a great method for anybody running any kind of a control panel, anything with a lot of different buttons on it.
Yeah.
Because you're limited on your interrupts, even if you chain them all together to interrupt them and then scan to see what was pushed.
Yeah, so you're using like a keypad.
Yeah. I think, some control panels, some of the ones I've seen on like industrial equipment, they can have quite a few buttons on them.
Yeah.
And you're not necessarily going to be able to get to them in a timely fashion, one quick jab. Even though humans are pretty slow, it still could get missed, especially if you're running something like an 8 megahertz board.
Yeah, and you're running,
you're running a little bit of extra code.
I've seen some chips recently that are in a 2 megahertz range, so.
And certainly that's on the lower end of your processing power. But, if that input is really critical, then you're going to want to, be able to record that event happening.
Yeah.
And so it's almost, that would be kind of a interesting method to use.
So, propose a, reverse question here. What's your favorite method, or do you have a favorite method? Like, what's your preferred method?
Well, I suppose just for, if I just have to pick one, I kind of like the interrupt method, even though it's limited by the number of, interrupts available on your microcontroller.
Mm-hmm.
Just because I can turn the interrupts on or off, whether I'm listening to them or not, with a single command. And so I can not actually be polling them at any given time through a loop, but I can turn the interrupts on. Now I'm sort of polling them in a sense. I mean, I'm waiting for that interrupt. I'm waiting for that event to happen. But at the same time, I can turn them off when I no longer care. I could do the same thing with jumping out of a loop.
Yeah.
But I think really, that ability to just be able to turn it on and off when I want, when I care about it, when I'm in critical code, and be able to do that very quickly and easily without having to jump through a subroutine.
Yeah.
I think that's pretty versatile.
There's some other weird ones I've seen where you'll sit there and wait for an event to happen. You'll just say, while this is not this, do this. And just sit here and go through this loop and go through this loop until the button's pressed, and then release it.
Well, yeah, even that's going to be used on, communication protocols on your chip. They're going to wait for your buffer to shift out.
Yeah.
So you're going to have your data stored into an 8-bit register, and it's going to move them out 1 bit at a time, and for a serial communication, and it's going to wait while you're doing this transfer.
Mm-hmm.
And that's one of those that you don't want to interrupt the process of that either. So
Yeah.
I think anything that's really critical, like those chip-to-chip communications, you have to protect the board. Anything like a data transfer, any other process that would be adversely affected by a timing change.
Yeah.
If you're counting, the example of having the rocket ship.
Mm-hmm.
You're not going to want to, go ahead and start your timer and then go do this other function over here and then go back to and see what time it was when you finished. You're going to want to, once you notice that, that first sensor triggers, you're going to want to pay attention and wait for the next one to trigger.
Well, I mean, there's other methods on that too. I mean, you can have it, there's 3, timers available. So then the timers do run semi-independently of any other code. So you can have, an external trigger the timer start, and then interrupt to read the timer end. So while between it starting and then the end part, it can actually do a couple of things beforehand, but, what else do you really need to be doing at that point?
Yeah, well, I think if you're building something like that, chances are you're building it for one function.
Yeah.
And that's probably to measure the exit speed of your rocket.
I mean, you might have an LCD, timing along with it. And that would be, or, like a 7-segment LED display to, show milliseconds, seconds, and minutes or whatnot.
Yeah. So, I mean, even there, you do have a couple options. You could start with an interrupt, then you could pull the pin. You could start on, not necessarily an interrupt, but allow the microcontroller to begin the process of the launch, so it knows when it began.
Yeah.
So I think it's just, it's just a couple of different concepts, but
Mm-hmm.
there's a lot of different ways that you can really, use them specific to what you're trying to get done.
Yeah. I mean, one thing, I definitely don't like locking myself into one methodology all the time. It's definitely very application specific, keeping in mind that can this be done with an interrupt? Can this be done by pulling?
Yeah.
And that's all going to be a matter of, what direct application. Like you're saying, the rocket one, you could really use an interrupt or, an interrupt to trigger timer, interrupt to end timer, then see what timer is. After rocket's long gone, and then display the time.
Yeah.
So, because I mean, if you're using the same microcontroller for both the LED, the LED display and the timer, you might run into a little bit of an issue. But if you're working, trying to, work it out, could be really, like split it into a second microcontroller, one that just does timing.
Yeah, and there's different ways that you could even work with that. I mean, I think for most people, the goal is going to be keep it simple.
Yeah.
The less things, less complexity, less things to go wrong, less cost.
Yeah, which also what's your resolution too?
Yeah.
I mean, if you, if it's real quick, like
that's going to get us into a debate of significant digits that I think we've had before.
Yes, significant digits.
So, if you're timing something like the speed of light, you're going to need something fairly precise.
Or
if you're going to time how fast it takes me to get across the room,
I got minutes.
You probably don't need a second hand. So,
sloth.
I could serve energy.
Yes. No, I mean, it is a matter of, if it's something like the speed of light, the greater distances you have, the easier it becomes to measure a little bit.
Yeah.
But even then, you're still, probably doing some weird math in a tooth gear over 5 miles.
I don't think that actually involves a microcontroller, but it could.
You still want to play with that.
It could.
I mean, we have the Granite Mountain. It's a good distance from here.
Yeah, and there's no trees in the way now.
Yes. Yeah, unfortunately. So, I mean, that's the whole idea behind this is what other methods, could we use in any other situation?
Yeah, I think, I might have my favorite, but I still think one of the more practical methods is the latch method. Just because, really, you've got a great guarantee there. You're not going to miss your data.
Yeah, if you're pulling, run through a latch. And it also helps a little bit with the debouncing too.
Yeah.
Once that's, button's triggered, that button's triggered until you come through and clear it. So, that's, definitely one, practicality. So,
And I think it's good to have just all of these methods in your toolbox. You don't want to be, like you said, limited to just one. You really don't even want to be limited to, 2 of these.
yeah.
If you're trying to fit a particular application, you want to have as many possibilities and potential solutions as you can, so you can find the best one.
Mm-hmm. So I hear SIAM's coming up.
Yeah, we're going to be presenting a couple of talks coming up here. That'll be after the 4th of July holiday. We're going to be doing one on power modeling and simulating that using a PID controller. Pretty excited about that, and it's actually going to be my first SIAM event. And then we have Scott Little, and you and I are also co-authors on his presentation
On the Eon black hole stuff.
Yeah, and that one's definitely out there. That's one where you let the research kind of take you.
Yeah,
On that one. It started out as a project, and I'm sure we'll get to talk about that at some point a little better. But that was a completely unrelated to anything string theory, anything relating to black holes, and just by making a few connections here and looking at it a little bit out of the box, Scott Little was able to take some of the work that had been done before and take it in that direction.
So again, all the ideas.
Yes.
Yeah, no, that's definitely. Got to say congratulations on your first SIAM event.
Yeah, thank you. Thank you. Well,
and
and you've got your first book coming out here.
Yeah,
So
first book's coming out. And then maybe one of these days we'll have a video on the whole pedal powered Strong Beast beer garden.
yeah, that's. I think that was actually when we first came up with all the ideas. So.
Yes. So.
But you also, I think you actually forgot the Valve's Pulse Jet in there too.
Yes.
It was a Valve's Pulse Jet Strand Beast beer garden.
Okay, so we didn't have the pedal
yeah.
power.
Yeah, no, I don't want to make drunk people pedal. That's kind of mean.
Yeah, the Vikings, they rode drunk. At least we think.
Well, and maybe that worked for the Vikings, but maybe not for the 21st century drinker. Might not be a great opportunity. You definitely want a sober person driving that one, unless you're going to integrate something like an autonomous vehicle in there as well.
Well, a sober person just has to steer it. They don't have to be the power source.
Yeah. That'd be kind of sad on a beer garden. You'd probably be lucky to have one sober person pedaling everybody around. So that'd be...
Maybe you get the amount of beer by how much you pedal.
No, that could lead to alcohol poisoning, I'm pretty sure.
Yeah, if you control it right. Microcontrollers.
Yeah.
Do we pull this one or do we interrupt it?
I think we need to interrupt that one.
Okay. So, yes, I hear on all the ideas, rambles of the Mad Fellows, and this one's been about pulling versus interrupting. And, well, it's a good idea to keep both in mind. When you're, critically doing critical timing, think about interrupts. If you're just kind of looking for input, look for input. This has been All the Ideas here on madfellowstech.com. If you have any ideas that you'd like to hear us ramble about, email them to alltheideas@madfellowstech.com.